Hello, and thanks for joining. My name is Jeff Demuth, and I'm a technology advisor at Insono, a cloud managed services company. If you've been following my channel for a while, I used to do a lot of geospatial research and benchmarking at AWS. I'll spare you the whole story, but with Amazon's 5-day return to office policy, I've decided to take a position that allows me to continue working remote, which is my preference. My new role isn't necessarily geospatial focused, but I'll still be doing architecture consulting, and geospatial workloads are really good for benchmarking. So with that, we'll jump into the video. Actually, maybe a little bit more background. I'm working on a large GCP project currently, and there's a similar debate to what you used to hear on AWS with Aurora versus CloudSQL. So in this one is AlloyDB worth the increase in cost compared to stock Postgres on CloudSQL. I'm going to do a whole video series, I think, on this. Basically, I'm setting up these environments, but I just did some quick benchmarking with QGIS that I thought would be good to share. I haven't done a video in a while. Also, I'll probably do a video on setting up QGIS on GCE. But I suspect the argument here is similar to what you used to see with Aurora Postgres and RDS Postgres, where Aurora was highly tuned for read transactions, and that came at the cost of write performance because I used to have to replicate those writes across multiple volumes. It was hard to keep the write performance in line. So you could typically squeeze more write performance out of a provisioned IOPS storage volume attached to RDS Postgres than what you could do with Aurora. They did recently release a new, I forget the name of it, but it's like a high IOPS feature for Aurora. I haven't gotten to test that yet. Maybe that helps. But for the test today, I pulled some places data from Overture, about 10 million rows of place data. That looks to be about a 2 gigabyte table in the database. And let's see what the performance looks like. That was kind of surprising. All right, so this is the query insights on the CloudSQL. And to write, it's about a 2 gig table, 10 million rows, close to about 35 minutes to write that out. Small instance. I don't know that a larger instance would have drastically changed these times. But now if we compare that, where'd it go? To AlloyDB, that actually almost took an hour to write that same amount of data out. I mean, so almost, like, these are both, I think 2 core 8 gig instances. Fairly stock, haven't done any tuning or optimization to these. And kind of right out of the bat, AlloyDB is twice as slow on writes compared to CloudSQL. And I'm not using a provisioned IOPS volume yet on CloudSQL either. So I suspect if I used a provisioned IOPS volume, you would even see that look even more favorable towards CloudSQL. And then for the test, that's basically pretty straightforward. I just, in QGIS, loaded in the places data. You can see it on the map here. We've got these SQL queries, but 10 million rows in each of the databases. You can see all the points on the map, and just basically copied this into the AlloyDB instance and the CloudSQL instance. Some of the other things I'm going to test is AlloyDB has a thing called a column engine. That's probably more so going to help on the read side again, not necessarily the write side. And actually they say that it'll hurt you if you've got high writes, because every time you write to the regular Alloy table, that then has to replicate that data to the column engine. But in theory, it should help for on the read side, basically. Although I did also read that it doesn't have geometry support for data types in the column engine. So I'm going to still do some testing with it. I'll have to convert the geometries to geohash, but it should be a fun one to see what the performance differences look like when we enable that. So thanks for joining. And yeah, if you like this video, like and subscribe. Thank you.